Figure 4 shows a bowl with circular cross-section. Initially, the bowl is empty. Water begins to flow into the bowl. At time t seconds, the water begins to flow into the bowl. The height of the water in the bowl is h centimetres. The volume of water V in the bowl is modelled as the equation V equals 4 pi h times h plus 6. The water flows into the bowl at a constant rate of 80 pi centimetres cubed per second. So just looking at the units there, that's dV by dt is constant at 80 pi. Show that according to the model, it takes 36 seconds to fill the bowl with water from empty to a height of 24 centimetres. So a height of 24 centimetres, we can use that with the equation here to say what the volume of the bowl is going to be. The volume of the water is going to be. So 4 pi times 24 times 24 plus 6 is 2,880 pi centimetres cubed. So that's the volume of water when the bowl is filled to a height of 24 centimetres. And we know that the water is flowing in at a constant rate of 80 pi centimetres cubed per second. So if I do the volume of the water divided by the flow rate to tell me how many seconds it's going to take, we get 36 seconds, as we expected to get. We know the water's flowing in at 80 pi every second, so after 2 seconds it would be 160 pi. After 3 seconds it'd be 240 pi. After 4 seconds it would be 320 pi, and so on and so on and so on. After 36 seconds, 2,880 pi centimetres cubed of water has filled into the bowl, so it would be filled to a height of 24 centimetres. Part B, find, according to the model, the rate of change of the height of the water when t is 8. So we need to find the rate of change of the height. So that's dh by dt. That's what I want to find here. So let me say dh by dt. Now I don't know what that is at the moment, but I do know dv by dt. So I can connect the rates of change here. I know dv by dt, so let me put a dv there, which means I need a dv here. And the dh by dv, I can work that out. I can differentiate the volume with respect to the height. So in order for me to do that, first let me expand those brackets. So we'll have 4 pi h times h and 4 pi h times the 6. And now I can differentiate v with respect to h. And I'll get 8 pi h plus 24 pi. Now that's dv by dh. I want dh by dv, so that's the reciprocal of that. And that's going to be multiplied by the dv by dt, which is 80 pi. Right, so I've got my expression for dh by dt now. I just need to know what h is when t is 8 seconds. Right, well I can work that out because I can work out the volume after 8 seconds because I know that the water's flowing in at 80 pi centimetres cubed per second. So if I say after 8 seconds, the volume is going to be 8 times 80 pi, which is 640 pi. So I know the volume of water is 640 pi after 8 seconds. Now I can use the volume formula now to work out what the height would be at that time. So we can say 640 pi is equal to 4 pi h times h plus 6. Now I'm going to divide both sides by pi. And I'm going to divide both sides by 4 as well while I'm at it. Expand these brackets and make the equation equal to 0. And I see that h is going to be 10. Obviously, I'm solving this equation, I get 10 or minus 16 as my solutions. Obviously, I'm ignoring the minus 16 because it doesn't make any sense in this context. But now I know that h is 10, I can substitute that into my dh by dt expression. So I will get 80 pi divided by 124 pi, which is, to 3 significant figures, 0.769 centimetres per second.